students, welcome to Young India Maths Summer Camp Session 2. Today in this class, let us continue the number system that we were discussing in the previous class. The first topic that we are going to discuss in today's class is integers. First, let us see what is meant by integers. So, integers is the combination of whole numbers and negative numbers. This is the definition of integers. So, as you are seeing here, 0, 1, 2, 3, 4, so on till infinity come under the whole numbers. Minus 1, minus 2, minus 3, minus 4, so on will come under negative numbers. Now, we have discussed what is meant by whole numbers in the previous class. Whole numbers is nothing but when we add 0 to the natural numbers, then it is whole numbers. Coming to negative numbers, when you add a minus sign in front of a natural number, you will get the negative numbers. We all know that 1, 2, 3, 4, so on are natural numbers. If we add a negative sign before them, then we will get the negative numbers. So this is what integers is. So this is how we will write integers in an order. Now if you just see till here, it is negative numbers. So these are all negative numbers. And if you see, this is all whole numbers. When you combine them, you get integers. To write integers in order, we have to write like this, which means this side also it is infinity, this side also it is infinity. So, if you just ask me how to represent integers, then we can represent integers either by using the capital Z or by using the capital I. We can use any one of them. Both are same. And now let us discuss the properties of integers. The first property that we are going to discuss is the closure property. So, according to the closure property, A plus B is equal to C and A into B is equal to C. According to this property, when A and B are integers, then their sum means addition and their product means multiplication. When you do them, this answer will also be an integer. So this is the closure property. Coming to the second property, we have associative property. According to this property, A plus B plus C is equal to A plus B plus C. This is how we write this property. And also A into B into C is equal to A into B into C. And this associative property under integers is only possible when all A, B, C belong to integers. Z here represents the integers. So, the third property that we are going to discuss is the commutative property. According to this property, A plus B is equal to B plus A and A into B is equal to B into A. Here both A and B are integers. This is very important. Only then the commutative property under integers will become true. If you just see, we have identities in integers. Under identities also we have two types. One is the additive identity. The second one is the multiplicative identity. So, if you just see, according to the additive identity, we have any integer plus 0 is equal to the same integer. Let us take an example for this. If we take A is equal to 4, 4 plus 0 is equal to, we can write this also as 0 plus 4, which is 4. Right. If you take 4 in your fingers and 0, which means nothing, then you get the answer as 4 only, right? So this is according to the additive identity under the integers. Coming to multiplicative identity, let us take here also a is equal to 4. Then 4 into 1 is equal to 1 into 4. 4 ones are 4. So it states that this property, multiplicative identity under integers, states that when any integer is multiplied with 1, then the answer is the integer itself. So students, now let us see how to represent integers on a number line. As you are seeing here, we will represent integers like this on a number line. So on the left hand side, you will have the negative integers. On the right hand side, you will have the positive integers, and in between them you will have 0. Students, I would like to tell one important point here. 0 is neither negative nor positive. So 0 is not positive, it is also not negative. So 0, we should not classify 0 under negative integers and positive integers. If you see here, I have represented the ends of the line as arrow marks, and the reason why I have represented them like this is because integers will be infinitely going on the left hand side. They will also be infinitely going on the right hand side. So there is no end to integers on both sides. So let us move on to the next topic, that is even and odd numbers. So students, when any number is divisible by 2, it is known as even number, and when any number is not divisible by 2, it is known as odd number. Based on these definitions of even and odd numbers, let us see few examples now. So here I have given you some examples of both even and odd numbers. Here if we see 0, 2, 4, 6, 8 are even numbers. 1, 3, 5, 7 and 9 are odd numbers. Not only till 9, but we know that numbers are infinite. So whenever numbers are infinite, this will go on in that manner. Now let us see, to understand this even and odd numbers topic very clearly, let us take one trick kind of thing. If you see here, by the definition, even numbers means they are divisible by 2. Let us check. When we take 0, 0 by 2 is equal to 0. By this we can tell that 0 is an even number because 0 is divisible by 2. If we take 2, 2 is also divisible by 2. So when we divide 2 with 2, we will get 1. Even 4 is also divisible by 2. When we divide 4 by 2, we will get 2. So whenever numbers are exactly divisible by 2, then they are known as even numbers. Whenever numbers are not exactly divisible by 2, then they are known as odd numbers. If we take 1, 1 is not completely divided by 2, because when we divide 1 by 2, we will get 0.5, which is not a whole number. So therefore 1 is a odd number. So students, now let us take few examples to understand whether a number is even or odd. If we see the first number, we have 56. Students, remember that whenever we are given a number, to find out whether it is even number or odd number, what we have to do is we have to check only its units place. How much big the number is, also we should check only the number's units place or ones place. So when we just see 6, We know that 6 is an even number. So 56 will also become even. Right? If we take the second number, which is 73, never bother about the second number, all these numbers. What you have to think after you get a question whether it is even or odd is only with the units place. So we know that 3 is not divisible by 2. So 3 is odd number. So obviously the whole number will be odd. Remember that whenever the units place, the number in the units place of any number is even, then the whole number, that is whole 56, will become even. Whenever any number which is in the units place is odd, then the whole number will become odd number. If we take the third example, we have 1 in the units place. We know that 1 is odd, so 21 is also a odd number. If we take the fourth one, which is 84, let us check the units place. In the units place or the ones place, we have 4. 4 is an even number. So obviously 84 will also become even. If we take the fifth example, we have 0 in the units place. So 0 is an even number. So obviously 100 will also become even number. Okay. Next, if we take this much big huge number, then ma'am, how can we tell whether it is even or odd? I told you that how much big the number is also, what you need to check is only the units place. In the units place we have 5. So we already know that 5 is an odd number. So this whole number, this very big number will become odd. So now I think the identifying even and odd numbers is very simple to you. Children, now let us discuss let us discuss rational numbers. Now the next topic that we are going to discuss is rational number. So children, the definition of a rational number is any number written in the form of p by q, where p and q are integers and q is not equal to 0. Now let us understand this very slowly. First of all, this is the simplified form of the rational number. First, we will see p by q form. In your earlier classes, in your childhood, you might have learned that whenever something is written like this, it is called as fraction. You might have learned this already. So this is known as the numerator. The upper number, the upper part of the fraction is known as the numerator and the lower part is known as the denominator. Right? You might have learned this in your previous classes. Now, coming to p by q form, any number which can be written in this form, you have a numerator and you have a denominator, and this can be written in the fraction form. And one more rule is, this is the first rule for rational number. Second rule is p and q, that is the numerator and the denominator should be integers. Z or I means integers. I already told this to you. So whenever any number can be written in the form of p by q and p and q, that is numerator and denominator, are integers, then you can call it as a rational number. But remember, there is also third rule, that is when p by q form is written, here q should not be equal to 0. Why q should not be equal to 0? Because when q is equal to 0, if we write p by 0, then it will become undefined. This is not right answer. This cannot be defined. It is not a number at all. So there are 3 rules for a number to become a rational number. First one is it should be in the form of p by q. Second one is the p and q should be integers. Third one is the denominator, that is q, should not be equal to 0. So children, let us see few examples to identify whether a number is rational number or not. If I am taking the first number, it is 5 by 7. What I told you? It should be in the form of p by q. So it is in the form of p by q, right? It is in the form of p by q. The second rule, so this is the first rule. The second rule is p and q should be integers. So 5 and 7 both are integers, right? 5 and 7 both are integers only. This is the second rule. And the third rule is this q, that is the denominator, should not be equal to 0. 7 is not equal to 0. This is the third rule. So 5 by 7 is a rational number. Coming to the second problem, this 81 by 6 can also be written in the form of p by q. Here 81 and 6 both are integers only, and 6, the denominator, is also not equal to 0. Coming to the third question, here both are in the form of p by q, and I already told you that 0 is also integer, 4 is also integer, so both are integers only. Here I told you that the denominator should not be equal to 0, so 4 is not equal to 0. Here you might get one doubt, ma'am, in the numerator you are having 0, then why should we call it as a rational number? Remember that whenever a rational number is in the form of p by q, here q should not be equal to 0. P can be equal to 0. So this 0 by 4 is also a rational number. Coming to the fourth problem, this can be written as in the p by q form. This is in the p by q form, and 4 and 0 both are integers, but the denominator is 0. I told you, when the denominator is 0, then it is not a rational number. It is not a rational number. So this is a rational number. This is a rational number. 0 by 4 is also a rational number. This is not a rational number. Coming to the fifth problem, 24 by 12 can be written in the form of p by q. Here both 24 and 12 are integers, and the denominator is not equal to 0. So this is also a rational number. So children, we will represent the rational numbers by using the capital Q. We will represent rational numbers by using the capital Q. So children, the next topic that we are going to discuss is coprimes. I am going to take few examples and tell you what is meant by coprimes. So if we see the first example, students, here we can write 2 as 2 into 1. 2 can be written as 2 into 1, and 7 also can be written as 7 into 1, right? So remember that when two numbers have only 1 as common, then they are known as coprimes or coprime numbers. Whenever two numbers have common as 1, their common multiple should be 1, then they are known as coprimes. So here we can tell that 2 and 7 are coprimes. Coming to the second example, 2 can be written as 2 into 1 and 4 can be written as 2 into 2 into 1, because when I multiply 2 into 2 it is 4, 4 into 1 it is 4 again, right? So 4 can be written as 2 into 2 into 1. Once multiply this and see whether you will get 4. You will get 4 obviously, okay? So here what we have is, we have 1 as common, we have 2 as common. So what I told you, whenever two numbers have 1 only as their common multiple, then they are coprimes. Here 2 and 4 have 1, but they also have 2 as their common numbers. Common multiples. So 2 and 4 are not coprimes. 2 and 4 are not co-primes. If we come to the third example, we can write 3 as 3 into 1. We can write 6 as 3 into 2 into 1. Here if we check, we have 1 as common, we have 3 as common. So here 1 is common, but we have another number 3 also as common. So 3 and 6 are not co-primes. Okay. Coming to the fourth example, we can write 12 as 6 into 2. We can write 27 as 27 into 1. So here if I just see, I can take 1 as common. Here nothing is common except 1. Only 1 is common. So 12 and 27 are co-primes. 12 and 27 are co-primes. So the next topic that we are going to discuss is the estimation of numbers. Many students will get confused how to do this, but it is really very simple. Let us learn how to do this. So before discussing the real topic, the actual topic of estimation of numbers, let us take one simple example so that you will be clear where we will use this estimation of numbers. So here I am taking a very simple example. Here what happens is, your sisters, you are in your sister's marriage. So now what your father will tell you is, first he will tell you to bring 251 plates, because 251 people or guests have come to your sister's wedding. So he will tell you to go and bring 251 plates, and these plates are not sufficient. You did not expect, but still many people came, many family members, relatives, many people came. So again what your father told, to bring 158 plates for your guests, right? Now what you will do, you will add them. You will add 251, you will add 158. If I add them, I am going to get, here 1 will come and it is 409. So you are going to the shopkeeper. You will go to the shopkeeper who will sell the plates, and will you ask him to give 409 plates? Will you ask him to give 409 plates? No, you will not ask him to give exactly 409 plates. What you will do? You will ask him to give 410 plates. Why? Because if you go and ask the shopkeeper to give 409 plates, he will laugh at you, right? That's why you will ask 410. This is where we will use the estimation in our real life. Not only in this, any example you take, we will use estimation daily in our life. But now let us come to the mathematics world and let us see how to learn this estimation. To understand this estimation, I will take an example for you. I have taken 50 to 60 numbers here. Now, if you have 1 in the units place, you will round it off to the nearest before tens place. Means if 51 is there, here 1 is there in the units place, you will round it off to the before number, that is 50. Before tens number. If you have 2, you will round it off to 50 only. If you have 3 in the units place, you will round it off to 50 only. If you have 4, you will round it off to 50 only. Now, if you have 5 in the units place, here I have 5 in the units place. Units place means ones place. It will be same. If you have 6, you will round it off to the next, that is 60. If you have 7, you will round it off to the 60. If you have 8, you will do it for 60. 9, then also 60. If you have 50, for example, it will be same. If you have 60, that will also be same. You need not round it off. It is the same. I have written 0 is an exception. If you have 0 in the units place, then the same number will be there. Let us take few examples. Here we have 24. If you ask me to round off 24, then what we will do is, as 4 is in its units place, we are going to round it off to 20. If you have 1, then we are going to round it off to 20. If you have 6, we are going to round it off to 40, because 6, if you have 6, we should go to the next number to 40. If you have 36, we should go to 40. If you have 9, we should write 50. If you have 70, as 0 is there here, you will write the same number as it is. Now let us see 3-digit number. How to round off 3-digit number. The first example that I am going to take is 512. If I take 512, then is it near to 510 or is it near to 520? Yes, because we are having 2, 12, it is near to 10. So we should write 510 here if you want to round it off to nearest tens. Okay? If you have 624, is it near to 620 or is it near to 630? It is near to 620. We have to write 620. Let me take one more example. 833. Is it near to 830 or 840? It is near to 830. So we are going to write 830. If I am going to take 966, is it near to 960 or 970? It is near to 970. So for 966, I will round it off to, it is not near to this. It is near to 970. It is near to 970. So children, if you see here, till now we have rounded the numbers till tens place. Now let us see how to round the numbers in hundreds place also. The first example is, whenever we have a number, we have 832 here. We should check, because they are telling us near hundreds, we should check whether it is near to 800 or 900. So just think children, to which it is near? Yes, it is near to 800. So the nearest value, the nearest hundreds, rounding off for nearest hundreds for this particular number is 800. For this number, it is 600. Remember that whenever you have numbers below 50, means 1, 2, so on till 49, they will come here in this category. Okay? When you have numbers above 50, that is 51, so on till 99, so on till 99, then that will come under the second category. Remember, this is very important point that you need to understand. So the next, rounding the next number 961 to its nearest hundreds value is 1000. Okay? 584 is, 584 is to 600. 238 is nearest to 200. I think you are clear with this concept called estimating of numbers. So children, next let us discuss this topic called Roman numbers. So let us learn what is meant by Roman numbers. Usually we will write numbers as 1, 2, 3 like that. According to the Roman numbers, we will write the numbers like in this order, in this manner. Before introducing you to Roman numbers, let me tell you some basics of Roman numbers. If we just see, if I put a line like this line represents 1, means this one. If I put a V symbol, something like this, then it will represent 5, this 5. If I put a X symbol, then it represents 10, which is this 10. If I represent L, if I write L, then it represents 50, this 50. If I represent C, then this represents 100. If I write D, then this represents 500, means this. When I am writing M, this represents 1000. It is required for your level, this much is required. Means if I put a single slash, then it is 1. If I put V, it is 5. If I write X, then that is 10. L, 50. C, it is 100. D, 500. M means 1000. Using these 7 only, we are going to write all other numbers from 1 to 1000 in Roman numbers. Only these 7 are required. Now let us see how to do them. If you see, we will represent 1 like this only. 2 is represented with 2 sticks, because if you just tell 1 plus 1 is equal to 2. So when you just combine 2 lines, then that is representing 2 here. 3 will represent 3. If you write 3 bars like this, then that is known as 3 in Roman numbers. If I want to represent 4, how can I write 4? I can write 4 as 5 minus 1. 5 minus 1 is equal to 4. So here we already discussed that 5 means V. So V we are going to write. And here this slash means 1. Whenever you write something before a letter, then that is meaning minus. Whenever you write something after one letter, that is plus. So how should I write 5 minus 1? Means 4. How should I write 4 in Roman numbers? Very simple. You are going to put 1 in front of 5. Means I am putting 5. V I am putting. Before V, we have to write 1 bar, which means 1. Okay? Here, the one that I have written here will represent what? It will represent this one. This 5 will represent this. So when I write like this, it is meaning that from 5 we are taking 1. From 5 if we take out 1, we will get 4. So this is how we write 4 in Roman numbers. So we already discussed that 5 is written like this. Coming to 6, we can write 6 as 5 plus 1. 6 can be written as 5 plus 1. So this is 5, and I told you that whenever we write some number after the letter, then that is means adding. We have to put 1 here. This is 6 in Roman numbers. So we are having 5 here. After 5 if we are putting 1 means plus. That's why we will write 6 like this in Roman numbers. So if you see, 7 is written like this because this is 5 plus, after 5 we are writing, so plus 1 plus 1 more 1, which is equal to 7. So 7 is written like this in Roman numbers. Coming to 8, we will write 8 like this in Roman numbers, means 5 plus 3 is equal to 8. This is 3 and this is 5. So 5 plus 3 is equal to 8. Coming to 9, we will write 9 like this. Why? Because x means 10, and if we write something before that, it means minus. 10 minus 1 is equal to 9. So we will write 9 like this, and 10 as usual, we will write it as x. If you see here, we will write 11 as x plus 1 means 11. X double 1 means 12. X means 10 plus 2 means 12. We will write 13 like this, 14 like this, and 15 like this. So we know that we are going to write L as 50 and 7 means this. So this is how you will write 57 in Roman numbers. So we know that D means, we can write this 854 as 500 plus 100 plus 100 plus 100 plus 50 plus 4. So 500 means D, 100 means C, again 100 means C, this 100 is again C. 50 means L, and we write 4 like this in Roman numbers. So how to write 854? We will write 854 like this in Roman numbers. So we can write 1024 as 1000 plus 20. Okay, 1000 plus 10 plus 10 plus 4. You can write this as 1000 means M, 10 means X, 10 means X, 4 is written like this in Roman numbers. So this is how you will write 1024 in Roman numbers. So students, we can write 65 as 50 plus 10 plus 5. 50 means L, 10 means X, 5 means V. So this is how we will write 65 in Roman numbers. So we can write 81 as 50 plus 10 plus 10 plus 10 plus 1, where I can write 50 as L, 10 as X, this 10 as X, this one as X, and 1 can be written like this. This is how we will write 81 in the form of Roman numbers. So I guess you are clear with the concept of Roman numbers. Now let us move on to the questions related to the topics that we have discussed in our today's session. So the first question is, which is greater among these two numbers? So this is one number, this is one number, which is greater? Now remember that there is minus symbol before them. There is minus symbol before the numbers. So how will we do it now? First, for this type of questions, let us take a number line. Here I will write minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, so on. So this also here, this side also it will go till infinity. On the right side also it will go till infinity. First, remember any time that whenever you have greater, least or equal to, the comparison question, what you need to do is, whenever any number is on the right hand side, that is greater. When it is on the left hand side, that is lesser quantity, that is lesser in value, right? So when we take 3 and 4, 3 is less than 4, means 4 is greater than 3 here. But when we take minus 4 and minus 3, on the right hand side which is there? Minus 3 is there on the right hand side. First we will have minus 3, then we will have minus 4. So which is on the right hand side is greater. So minus 3 is greater than minus 4. For solving these kinds of questions, what you need to do is, you need to remember one small tip, that is, any number which is on the right hand side is greater than the number which is on the left hand side. So this is right side, this is left side. So this is greater value and this is lesser value when compared to these two numbers. Okay? So children, the next question is, are 6 and 12 co-primes? Are 6 and 12 co-primes? We will write 6 as 3 into 2 into 1, and we will write 12 as 3 into 2 into 2 into 1. Here 1 and 1 both are common, 2 and 2 are common, 3 and 3 are common. So as there are many numbers which are many multiples which are common, 6 and 12 are not co-primes. So 6 and 12, they are not co-primes. Okay? So children, the next question is this number even or odd? That is the question. What I told you is, whenever you are given these kinds of question, you should not be scared, because it is a big number. You should not be scared. What you need to do is, you should see its units place. We have 9 in its units place. So 9 is a odd number. So automatically this whole number will become odd. This whole number is odd. So odd is the right option. So children, the next question is 1 a rational number? So let us see whether 1 is a rational number. 1 can be written in the form of 1 by 1, because 1 by 1 means 1 only, right? So 1 can be written in the form of P by Q, which is the first rule. 1 can also be here both. I told you that 1 is also a integer. It is also an integer. So both P by Q, that is both 1 and 1 are integers. So 1 is a integer, means the second rule is also obeying. The first rule is obeying, second rule is also obeying. Coming to the third one, this denominator should not be equal to what? It should not be equal to 0. So 1 is not equal to 0. So the third rule is also obeying. So 1 is a rational number. 1 is a rational number. Remember that I told you that we will represent rational numbers by capital Q. So 1 is a rational number. So students, the next question is 2200 in Roman numbers. We can write 2200 as 1000 plus 1000 plus 100 plus 100 means 1000 means M, again 1000 means M, 100 means C, 100 means C. So this is how we write 2200 in the form of Roman numbers. So this is all for today's class, students. You will be given a worksheet. Please try to do that worksheet in your notebook. I would recommend you to maintain a separate notebook for these classes because it will be helpful for you during your revision. Hope you have understood today's class. Thank you all for attending this session. Meet you in the next class.